The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to an ANOVA Systems webinar. My name is Sam Bromley and I'm going to show you a process to create detailed drawings of piping route designs, specifically of particular defined spools. So before we begin, there's a few things I'm going to point out. This video is going to be recorded, so don't worry about taking any notes at all. You're going to get a chance to watch this again if you want to. It's going to be put on the ANOVA System website, and that will be done shortly after I've done this webinar. One last thing. Any questions that you'd like to ask, you'll find that on the right-hand side, on the GoToMeetings dialog box, there's an area called Questions. Please feel free to ask any questions throughout the entirety of the webinar. I will answer any questions that you've got at the very end. Okay, so before creating the drawings of routing assemblies, the routes need to be created, quite obviously. Using the add-ins within SolidWorks, the routing add-ins. Now, if you're unfamiliar with the process involved in creating piping routes, there have been recent webinars in, I think, routing and piping setup and piping routes as well. So if you're unfamiliar with those processes, you can always catch up on any of the videos that have been put on the ANOVA Systems website. Recordings of, if you go to the ANOVA Systems website on the right-hand side, there's a video section and you can browse and find those in there. So feel free to sort of have a bit of a catch-up information with those videos. Okay, so let's get cracking. We're going to move over to SolidWorks and I'll sort of explain what we can see here. So this is actually quite a large general assembly of a skid for the oil and gas industry. Now initially we're going to have a look at this skid here, and what we're going to do is we're going to break down and have a look at different approaches in creating the drawings for the particular spools themselves for the routes. Now the first area we're going to have a look at is actually this sub-assembly. And I'll show you the sub-assembly because it's not quite obvious what it is yet. There's a sub-assembly here of a particular route, okay, highlighted in blue. Now, if I just zoom into here, something I want to point out before we start creating and have a look at these drawings themselves. The routes themselves are actually predefined and positioned in sort of in regards to existing geometry. So, for instance, this flange here that's connected to the tank, and likewise any other flanges that are connected to the tank or existing spools, are connected with our route. So what you will find is there's a very limited amount of dimensions when it comes to create the drawings themselves. Then what we'll do is we'll go through a process to put those dimensions in ourselves. So because there's minimal amount of drawings, there's actually going to be an impact on the insertion of the dimensions when it comes to create the drawings themselves. So due to this, we'll insert reference dimensions. So what we'll do is we're going to open up this sub-assembly here, this route, and any routes that are created automatic virtual sub-assemblies within the general assembly itself. Now, as we can see here, I've actually inserted a few dimensions already into this spool design. You can see we've got dimensions here and here. Now, these are reference dimensions. Okay, so these are referencing the existing geometry. They're not driving the geometry itself. The geometry is driven by the positions of the existing spools. But what we're going to do is we're going to go back inserting a few more dimensions in here, thinking about what sort of dimensions we think are going to be useful. So, for instance, the length of this from corner to corner here, the entirety length of this section here, perhaps up to the other components from the edge of the spool. So I'm just considering what type of dimensions are going to be useful and what type of dimensions I'd like to bring through into my drawing. So perhaps rads on these corners, like so. And finally we'll also put in one from point to point here as well, so from corner to corner. But let's say that's enough dimensions for the time being. Now, what you will notice is that some of these dimensions are purple, like these ones here, and the ones that I've just inserted are still grey. The reason being is the purple dimensions are what we call not marked for drawing. Okay, so they've got a particular status associated to that dimension. Now, the reason why they've got that status, you'll see in a moment. But what I'm going to do is I'm going to set all the other grey dimensions to not marked for drawing. Quite simply, I'm going to right-click on the dimension itself, and you'll see on the right-click menu, we can say and turn off marked for drawing, which will mean subsequently it is unmarked for drawing. When I do that, it turns purple. And I'm going to do that to each one of these. So each individual dimension itself is going to be not marked for drawing. Make sure there's any more. There's one there. Okay, I think that's the lot. So they've now all got that status as not marked for drawing. Now what we're already doing now is taking it to drawing level and creating a drawing from this spool. So much like any other process in SolidWorks, it's very similar to creating any engineering drawing. We've got our assembly created. We're then going to make drawing from assembly. Select a particular template, and I'm just going to drag and drop some views in. Now those are a little bit too small, so we'll just change the scale in a second. I'm also going to put in an isometric view as well. Now let's change the scale of our sheet here, because those are quite small. Say 1 to 25 should do it. Yeah, that's much better. And we'll just move these around because we're going to put the dimensions on in a second, and we don't want those to be intersecting or interfering with our isometric view. Okay. Now, what I'll do is I'm simply going to select the view itself. We're going to go to annotations and model items. So for those of you that actually use model items, you'll be familiar with this, but I'll explain to those of you that may not. This is essentially an import tool for dimensions, annotations, reference geometry, and we can insert any of those dimensions or annotations which were inserted at part level or at assembly level into our drawing sheet itself. So any work and processes that we do when we go to model or go about creating those assemblies can be imported directly into our drawings. Now, there's a few options we have to specify first off. We're interested in inserting it to the entire model, but likewise you could select a particular feature, component, or the assembly itself. We're going to go for entire model. We're going to import items into all views. And quite importantly, what I need to ensure that I've got turned on here is not marked for drawing. Because if you remember, all those dimensions that I inserted, those reference dimensions, have been specified that their status is not marked for drawing. And what we'll do is we'll turn off this button here. And that particular button is all the other dimensions that may be associated to the drawing itself. So for instance, the diameter of the flanges. Okay. Now all that other information we don't want to come through. We just want those reference dimensions that I inserted. The last option we're going to ensure that we've got turned off here is use dimension and placement in Sketch. If you think about when I inserted those reference dimensions, I could have easily projected them quite far away from the model itself, which means if that option's turned on, it will duplicate the projection that's been created and they'll be really far away from the drawing views. So I'm going to turn that off. Hit the tick and all the dimensions come in. And those are just the dimensions that I created as reference dimensions. Now, I think this model actually uses inches, so we're just going to change the system here to inches. And just do a bit of general housekeeping just to move these dimensions around so it's a little bit neater. That's better. Now, not to say we can't obviously go about putting our own dimensions in at drawing level. Now, a nice way to do that would be to select the view itself, and within that view, turn on the 3D sketch of the route. So if we drill down into the drawing view itself, we'll find down here we've got the route. And what we'll do is we're going to show that 3D sketch. So we essentially get all the center lines of the pipes and the flanges that have been created. That means I can then go about putting in any other smart dimensions at drawing level into my drawing. And this can be done with any of the views themselves. So likewise, not to say that just because I've done it at at sort of the sub-assembly level doesn't mean that we can't do it at drawing level as well. Now what we're interested in doing next is looking at this isometric view. And what I'm going to do is I'm going to go back inserting a bit of materials. Now the template that's being used here is actually a piping bill of materials template. Now it's no different to a normal bill of materials, apart from this one has been set up to ensure that there's particular columns that are set to useful properties that are important for the creation of piping drawings. Likewise, the most important would probably be the length. So we're going to use that piping bill of materials there. Now these are quite large, so what I'll do is I'm just going to shrink down the text on this. And then just resize it. Okay, so what we get is, we get all our normal information that we'd expect to get through in a bill of materials, the item number, the quantity. We also get those part numbers, okay? We get description, we also get that length. So each individual pipe here that's been created in the route, the length of those has been automatically created, and that is parametric information that will update if your route changes, and it gives us that length. Now, a bill of materials isn't hugely important without having a set of balloons. So quite simply, I'm going to auto balloon this view to get those balloons in. Now, those of you that may not be familiar with these, you might notice that if I click on one of the balloons themselves, we get these magnet lines, and they just allow us to sort of help with our housekeeping, I suppose, and move around our balloons in an orderly fashion. And there we have a very manual approach in creating a piping drawing. What we're going to have a look at next is we're going to go back to the General Assembly, and we're going to have a look at creating a particular drawing of maybe perhaps an area of the existing spool. So we're still looking at this spool here, and what if we want to subdivide that? Okay, so we're only interested in creating perhaps a drawing of this section of the spool here. Now to do that, what I'm going to do is I'm going to go to routing. Okay, so make sure you've got the add-in turned on to get the routing menu, and then to piping. And what I'm going to do is I'm going to define a spool. So I select the spool that I'm interested in sort of subdividing, I suppose you could say. It's this one here. I'm going to give it a name. Got defined spool segment, and then what I do is I specify within these boxes here which sort of sketch line itself is going to be that particular spool segment. So it does a lot of dynamic selection for you here. I simply select the spool segment itself from that sketch, and the two spool components, the T and also the flange itself, are picked up automatically. I'm just going to accept that that is now a new sub-defined spool of my overall route. Now what you'll find is we get a folder down here called Define Spool Segment. We can expand it there, and each individual component, including the pipes themselves, are now defined within that subfolder. Now what this means is, just exit the editing of that. What this now means is that we can create a drawing from that particular sub-segment. Now the next approach we're going to have a look at is a much more dynamic approach. It does a lot of the work for us because it considers what we're going to need within the drawing itself, and it adds it in automatically. I'm going to go to routing and piping, and what I'm going to do is I'm going to go straight to pipe drawing. So that's going to create an automatic drawing from the pipe selection that I select. Now we're interested in, again, this sub-spool. And what that will do is it will show me the spool selection of that particular sub-assembly. So if you remember, we created that new spool called Define Spool Segment. So I can select that particular segment. And what it also does is it asks me a few options of what I'd like to do when I come to create the drawing itself. What sheet format I'd like to use, what bill of material I'd like to use. Do I want to insert auto balloons? Okay. So we will do that. We'll accept these. I'm not going to show the root sketch though. We can do a little bit more with that in a second. The reason being is it shows the full root sketch, whereas we're only subdividing the particular segment of it. So we don't want to show it all, you see, and it sort of hangs off the edge of the drawing. I'm also going to leave it using this standard bit of materials. The reason being is I want to show you something here. If I specify that define spool segment and hit the tick, it starts to create the drawing for me automatically. Now what it does ask me is it says the bill of materials template that you're about to use actually has no length field. Now that's obviously an important thing for me to ensure that I've got within a piping drawing. Would you like to add it now? The answer is yes. And we'll neaten this up a little bit because we've got a few dimensions we won't necessarily need. And what you'll see, it uses a particular bill of materials template. It dimensions. It also inserts balloons and the bill of materials automatically for me, and the ever so important length column. Now there's not a huge amount of information in these other sections here. They are custom properties. Some of those we're going to have to add ourselves, like vendor. So I don't know what vendor we get those from. So we'd have to fill certain information out ourselves. Now just to show you, that process isn't just available for something that we've defined. So we create a subdefined spool. We don't just use this process for those defined spools themselves. If we go back to the general assembly, if I do the same process again, routing and piping, pipe drawing, we'll select the same section again. If I select this very top section here, it's going to select the whole thing. We'll use the same templates. The answer will be yes again. We'd like to add a length field within the bill of materials. And there we have, we'll get rid of some of these dimensions. Granted, you wouldn't necessarily dimension an isometric view. It's sort of auto-insert those for us. Get rid of some of those, not all of them. And what we'll see is we get a few more sort of bits of information here, hence the material we've got on some of these components here. We're getting a weight out as well. And just to show you again that we can actually do it on just a sub-assembly of the general assembly as well. It doesn't have to be a defined spool. So that's a much more dynamic process. Okay, so it automatically creates that bit of material, auto creates a drawing, bit of materials, and auto balloon view of the selected spool. A much quicker process than the manual approach, I think you'll agree. Okay, now the final creation that we're going to have a look at is that of PID drawings. So for those of you that aren't unaware or familiar with these, they are piping and instrumentation diagrams. So they're essentially schematics for piping designs. So we've got sort of a pre-made PID view here, drawing. And what you'll see is they're essentially sketch elements, okay? The individual entities, a lot of them are actually blocks as well. Now, before we sort of show you how to go about inserting the blocks into here, I just want to run through a process and just show you how to actually download the library of these components themselves, these individual blocks. Now, within the design library, on the right-hand side, there's a section called SolidWorks Content. Now, if you activate SolidWorks Content, you'll find there is a subfolder called Blocks, and this is the folder that you'd want here. Okay, so you can download the hydraulic blocks here. There are electrical blocks as well. So it saves you having to actually go about creating those blocks yourselves. Now I've got those downloaded, and what we're going to do is we're going to concentrate on this area here. We go about inserting the blocks themselves. Now first off, we're going to create extra piping here simply by sketching a straight line. And we can add relations here to ensure that the sketches sort of line up with each other. And we can also resize those just by dragging them. And what I'm going to do in this area is I'm going to go back inserting some blocks. So I'm going to my design library. I'm going to insert a flange simply by dragging and dropping, and I can link those to the existing edges themselves. Actually, want another flange there. Oops. Drag and drop another flange in. I'm just going to place that because I want it to be connected here. Simply drag and drop it. And between here, we're going to have a two-way valve. So if you drag and drop that in, sort of snap it to a position, and I'm just going to drag and drop and connect those flanges to it. So we can, and it is a sort of an assumption that we might not be able to go about creating those schematics in SolidWorks. Definitely a manual approach that we're doing there. Okay, it won't create those drawings directly from the piping designs that you've already created. Now, this sort of brings us to the end of what I want to show you here. Okay, so hopefully we've seen a few processes to help with the creation of those piping drawings. And what we'll do now is we'll take a moment to answer any questions that you might have about any of these processes at all. Now, what I will do is I'll sort of mute my microphone for the time being. And again, any of the questions that you might ask, please feel free to answer those in the questions dialog box in the GoToWebinar section. Like I say, I'll mute my microphone. For those of you that want to shoot off, you can do so if you wish. But I'll close down the webinar when all those questions have been answered, if anyone's got any. So for those of you who want to shoot off, I want to thank you for watching. Now, if you've got any sort of further questions at all, please do get in contact. You can send us an email over to support@innova-systems.co.uk, or equally, just give us a call on 01223 200 699. Before we go, a few things I'm going to point out. Our future webinars on the 20th of December, so just before Christmas, we've got advanced weldments in SolidWorks. After the new year, we're looking at, first off, using circuit works in SolidWorks, so PCB design. And then on the 10th of January, we've got SolidWorks electrical. So, like I say, I'm just going to mute the microphone. Any questions, please feel free to ask. And again, thanks for watching.